Welcome to the ftir.fun infrared learning series.
This episode, Ep01, what is infrared light? From visible to the invisible world. Then close with a checklist.
Next, objection. A thermometer reveals the hidden world.
In the spring of 1800, a British astronomer William Herschel, 1738-1822, was working on a problem seemingly unrelated to astronomy. He wanted to find a suitable glass filter that would allow him to safely observe the sun without burning his eyes. He noticed that different colored filters transmitted varying amounts of heat. Herschel used 3 mercury thermometers with their bulbs blackened to better absorb heat, one in the violet light region, one in the red light region, and a third placed just beyond the red in a region completely dark to the naked eye as a control. Next, the electromagnetic spectrum position of infrared light. To understand infrared light, we need to place it in the broader picture, the electromagnetic spectrum. The electromagnetic spectrum encompasses all electromagnetic radiation arranged by wavelength or frequency, from gamma rays with the shortest wavelengths and highest energy to radio waves with the longest wavelengths and lowest energy. The spectrum spans at least 16 orders of magnitude. Next, i.e., 3 subdivisions of infrared, near, mid, and far infrared. Infrared light is not a uniform whole, based on wavelength and the mechanisms of interaction with matter. It is further divided into 3 subregions. Table 2. 3 subregions of infrared light. Data sources. CSDN infrared family over UK collection notes. Columbia University Lab Manual IU Mappery. Next, IEM with the number CMY, the common language of spectroscopists. If you look at any infrared spectrum, you'll notice the horizontal axis is not labeled with wavelength, mm or mu-m, but with a less common unit wave number. In units of cm, how many waves per centimeter? Wave number, denoted nu-re, is the reciprocal of wavelength, defined as the number of waves per unit length. Next, infrared light in daily life. Infrared light is not only found in the laboratory, it is ubiquitous. Table 3. Infrared applications in daily life. Data sources. NASA EPIC Educational Resources. Wuker Guide Zheng. Next, why is mid-infrared 2.525 micrometers the main battlefield for molecular analysis? Back to our key question, why do chemists almost exclusively use mid-infrared? The answer lies in a critical physical correspondence. Next, our rule for thought. In Herschel's experiment, why did the thermometer need to be blackened? If the wavelength of infrared light is 6.67 micrometers, what is the corresponding wave number? Finally, the drill actualists. Make sure you can recall each item. Core knowledge point. Key points. Discovery of infrared light. Discovered in 1800 by Herschel using prism plus thermometer. Experiment. Position in the electromagnetic spectrum. Wavelength 780 nanometers millimeter between visible light and microwaves. 3 infrared subregions. Near, high penetration, high characteristic. Absorption, Fourier, thermal effects. Central role of media. Vibrational frequencies of chemical bonds happen to fall in this region, 4,400 centimeters. Wave number cm. Reciprocal of wavelength proportional to energy. Standard unit in spectroscopy. Spectral plotting convention. From high wave number, left, to low wave number, right. Historical habit. That covers the required stencil for this episode. Practice with real spectra on ftir.fun, and continue with the next lesson.